Okay, so let's look at now using distance, the actual distance formula. The distance formula, if you remember, is d equals, here we're looking for distance. Remember, length is the same thing as distance. So length and distance are the exact same thing. They're used interchangeably. So I'm going to find the length of the segment that connects these 2 points. That means I'm drawing a segment with these 2 endpoints. So this segment's somewhere on the coordinate plane, and we got a point at 3, 1, and we got a point at 2, 4. And I want to find the distance between these two guys. And if you remember, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And if you remember, we derived that from the Pythagorean Theorem, and you can see that in one of the other videos under the distance and midpoint playlist. But it will show you how we got this from the Pythagorean Theorem. This is basically the Pythagorean Theorem right here, just already manipulated so that c squared, which is our distance, is now c, which actually is c squared if we've taken the square root. C is our distance, and then this is the a squared plus b squared element. So anyway, we've got a video on that set up on the distance and midpoint playlist. So let's find the distance between these two guys. All right, first things first. I always rewrite the formula with all of the signs, all of the operations, except for what I'm plugging in, and that always helps me ensure that I don't make mistakes with signs, especially negatives. So let's look at x2 and x1. Now, it doesn't matter which one of these is x2, y2, and which one of these is x1, y1. That's just the way the formula is written. Sometimes you'll see the formula written x1 minus x2 squared and y1 minus y2 squared. Sometimes you'll see the y squared version here and the x squared here. It doesn't matter as long as everything's paired properly. So I'm going to look at my 2x coordinates, which in this case are 3 and 2. So I'm going to make 3 here, this entry, and 2 this entry. So this is the difference in the x coordinates, which actually tells me how far apart my points are horizontally on the graph. That's where the right triangle comes in from the Pythagorean Theorem. And I'll show you a picture of that in just a second. So now let's look at our 2 y coordinates. I've got 1 and 4. Now, since I used the 3 first for x, I have to use the 1 first for y. Because if this is x2, 1 has to be y2. That's what those little subscripts, the 2 and 1 and the 2 and 1, are telling you. Those aren't exponents. They're just telling you that this x goes with this y, and this one goes with this y. So I have 1 and I have 4. So now I'm going to move on. I must keep my parentheses. 3 minus 2 is 1, so that's 1 squared, plus 1 minus 4, which is negative 3 squared. You've got to keep your parentheses here. If you drop the parentheses, you're going to get a negative number, and you're going to get the wrong answer. We are squaring the whole thing, negative 3. Okay. So for our next step, what we're going to do is I'm going to combine these. So the distance is going to equal 1 squared is 1. Negative 3 squared becomes positive 9. And so 1 plus 9 is 10. So the answer for our distance is the square root of 10. Okay? Now, we can do the square root of 10, or we can do it as a decimal. It's going to be approximately 3.1, something in there, something in there. You can use your calculator, but unless I tell you to convert it to a decimal, leaving it as the square root of 10 is fine. Now, how does this tie into the Pythagorean Theorem? If I were to actually put these points on a graph, I've got 2, 4, which is this point right here, and then I've got 3, 1, which is this point right here. And I want to find the distance between these two, right here. Sorry for the sloppy drawing. I have my horizontal distance here, which is 3 minus 2, because I'm going from 3 to 2. That tells me that that part of the triangle is 1. And then I have my vertical distance, which is here. And remember, that makes a right triangle. In my vertical distance, I'm going from 1 to 4, which is 3. So I could do 1 squared plus 3 squared equals c squared, which is my distance. And when I take the square root of both sides, I get the square root of 1 squared plus 3 squared, okay, which is actually, and it doesn't matter here because we counted to make it positive, you'd get the square root of 10 equals c. Same thing. So that's how we use it with the Pythagorean theorem. So let's look at the next example on distance. And now we're looking at number 26. So number 26 is the same thing. We're just trying to find the distance using the simple distance formula. If you want to graph it and use the Pythagorean theorem in vector directions, using vectors and adding vectors, that's fine. The distance formula gives us a nice shortcut. So again, it's x2 minus x1 squared plus y2 minus y1 squared. So I'm going to look at these 2 points, and I'm going to find the distance between the 2 of them. So I'm going to rewrite my distance formula here with all of my operations in my symbols except for what I'm inserting into the equation. So let's look at our 2 x's, -1 and -3. So I've got -1 minus -3. Okay? Then I'm going to look at my 2 y's. I've got 4 and -4. Now here's why I put the symbols in first. A lot of people would see 4 and -4 and your brain automatically shifts to 4 minus 4, which is 0. But remember, you're taking the difference, the subtraction of the 2 values. So it's 4 minus -4. So what do you think's going to happen when I have a minus a negative? Well, here I have -1 minus a -3. Minus a negative is the same thing as plus. 2 negatives together make a positive. So that's -1 plus 3, which is 2. So I've got 2 squared. Then I've got the double negative here. So I've got 4 plus 4, which is 8. So 8 squared. And then I'm going to move that over here to this side because we're running out of room. So the distance is going to equal 2 square root of 2 squared, which is 4, plus 8 squared, which is 8 times 8 is 64, so the square root of 68. Now if you were to write that as a decimal, it's going to be approximately 8.2, somewhere in there, but we're not requiring you to write it as a decimal. So that's how you find the distance using the distance formula on number 25 and 26.